The U.S. Army just revealed the replacement of the Blackhawk. Competitors are polishing their products as the Army gets ready to choose an upgrade to the venerable but aging Blackhawk. This fall, the Army is slated to make a decision on its FLRAA program, Future Long-Range Assault Aircraft. The Army has declared a quiet period on the competition in anticipation of the decision. As the Army gears up for a great power confrontation with China and Russia, Future Vertical Lift, which comprises FLRAA and the service's Future Scout helicopter, is one of the top 3 main modernization objectives. FLRAA is expected to be installed in the 1st Army unit by the end of the 2030 fiscal year. Both teams have remained active despite the impending contract's decision, which they both have been aware of. Boeing-Sikorsky and Bell Textron executives who work for competing aerospace companies have said they will use the upcoming months to further qualify and test their platforms as well as increase their use of digital manufacturing. The Blackhawk, a platform created in the 1970s, has been completely replaced by platforms created by each team. Hey guys, welcome to our channel Future Warplanes, where we tell you about military fighter jets, military drones, military planes from the currently famous in the air to the most advanced around the world, and in addition for the latest episodes, we'll be covering all military defense news. So stay with us till the end of the video, because you don't want to miss out on any of this information. With the rivalry between the remaining competitors, military industry giants Bell and Lockheed Martin is fiercer than ever as the U.S. Army is just weeks away from making a decision for the future long-range assault aircraft. The businesses are pursuing vastly dissimilar strategies in their efforts to succeed the iconic H-60 Blackhawk. The V-280 Valor from Bell is a scaled-down version of the V-22 Osprey tiltrotor, whereas the Defiant X from Lockheed is a compound helicopter with a brand-new design. Both have advantages and would be a significant step up for Army aviation. The Defiant X, however, is the obvious choice when factors like infrastructure, life cycle cost, training, sustainment, and most crucially, mission are taken into account. The Defiant can readily fit into the Army's current infrastructure because of its similar footprint to the H-60, saving the Army the expense of modifying facilities, a cost that includes both labor and material expenditures. The airframe, according to supporters of the V-280, can fit in the hangars now used by the Army for its attack and assault helicopters. The difference in width between it and Defiant is more than 50%, at 82 feet. There is a difference between squeezing in and perfectly integrating with the hangar and ramp infrastructure that already exists. The Defiant boasts larger rotors than the V-280 despite its smaller size, with all the advantages it brings. Defiant has two 53-foot, 6-counter-rotating coaxial rotors, which provide it more lift than the 35-foot diameter propellers on V-280, and in comparison to the V-280, the Defiant has a much larger rotor disc area, which results in less disc loading for a given gross weight. In general, the Defiant is superior at handling, lifting more, and hovering higher than the V-280. It keeps a better visual environment while also being more flexible. For the fundamental reason that the V-280 is a tilt rotor with both helicopter and fixed-wing modes and is not a helicopter, choosing it would result in increased training needs for pilots. Phase 1 rotary wing Common Core training does not include fixed-wing instruction for Army pilots. The V-280's Phase 2 training requirements are much higher than those for the Defiant X. However, because the majority of tilt-rotor flight time is spent in aircraft mode. An additional control provided by a tilt rotor is prop rotor tilt, which is unheard of in aviation. Since there is a delay between the control input and the control response, this is a high inertial control. As a test pilot with expertise, I can say that you need specialist training to grasp this control, especially in crowded formations and small landing areas. On the other hand, the Defiant's compound architecture makes it simple to move from Phase 1 to Phase 2 training, making it a go-to-war aircraft. While supporters contend the V-280 is a helicopter for training purposes, they believe that the same aircraft should be treated as an airplane for maintenance. After all, having fewer moving parts equals lower maintenance expenses for airplanes. Performance in the past does not support this. Only 4 out of every 10 V-22s were discovered to be combat-ready in 2019. The V-280 may operate in a variety of modes, including conversion, helicopter, and airplane. It is necessary for all elements regulating those modes to function. The Defiant is less complicated and more sustainable because it has a single mode, fixed rotors, and a fixed propulsor. Even more alarmingly, the V-280 has a design flaw in that the engines are fastened to the wing, as seasoned defense Airlines journalist Richard Whittle noted in 2016. One side effect of mounting the engines on the wingtips is that as the V-280 rotates upward, a huge hole in the forward-facing wing opens up beneath the nacelles. Bell engineers thought about trying to seal the hole to keep debris from getting into the nacelle there. Instead, they made the decision to accept the danger they deemed to be minor. Encounter in the Middle East and Afghanistan show the effects of sand and dust on aircraft, with everything from engine degradation to clogged filters and blade erosion serving as a key source of sustainment cost in harsh settings. The potential of corrosion from rain and salt water penetration is also present. It'll be interesting to see whether the huge hole in the V-280's helicopter mode affects sustainment. The configuration of the V-280 may have a specific impact on sustainment, according to experience. The landing zone, sometimes known as on the X, is where Army aviation considers the operation to be completed. Landing is therefore an important part of any air assault. The configuration and adaptability of the Defiant are demonstrated to be superior to the V-280 in this situation, and the Defiant can sustain the same missions, tactics, and techniques as its Blackhawk predecessor in the same formations and kinds of constricted spaces thanks to a footprint that's similar to the H-60. As Bell's own Frank Lazzara, director for the FLRAA Sales and Strategy, explains, the V-280 can operate in confined spaces, but doing so requires adapting flight plans. If we were in a confined space, we could still land in the same footprint as a UH-60, but we, speaking of the V-280, might need to land in a different axis, Lazzara says. For the pilots and assault forces, the mission becomes more difficult and dangerous when the direction is changed during the crucial landing phase. Assault forces and V-280 pilots have fewer alternatives where they are most needed, on the X, due to a lack of formation selection flexibility. The V-280's design requires that the planes separate in what is known as a trail formation, single file, one after the other, in order to comply with the tactical requirements outlined in the 101st Airborne Division's Gold Book. Due to the rotor weight created by the trail formation, tilt-rotor aircraft face significant difficulties. In April 2010, an Air Force Special Operations CV-22 lost control when passing through the lead aircraft's rotor wash. The inquiry that followed concluded that CV-22 wake modeling is inadequate for a trailing aircraft to establish accurate calculations of safe separation from the preceding aircraft. The gap between the prop rotors on the V-280 makes it subject to the same occurrence by design. This causes an uncommanded roll-off, a lift asymmetry in which one prop rotor is immersed in downwash and loses lift while the other continues to supply it. Similar restrictions on design do not apply to the Defiant. Without making any tactical adjustments, it satisfies the Gold Book separation standards and stays clear of the dangers associated with altering the landing axis and uncommanded roll-offs. And I think that's going to do it for today's video, guys. We sincerely hope that you enjoyed it. If you did, please click on that like button and make sure you share with your friends and family. And if you have any questions or comments for us, as always, please share them with us in the comment space below. Don't forget to subscribe to our YouTube channel to see even more of our incredible videos. And you can also click the bell icon to make sure you subscribe to our channel. Hey, thanks for hanging out with us today, and we'll do it again soon.